inputs in order to get the better results. So there is in the market and now a system. And then in the lab we proceed hello, dear friends. The presentation is about a digital approach for a lithium disilicate case with a unique way. Normally, when we do pressable or pressable with CAD/CAM milling, there is a lot of human work. I love human work. I'm a not so digital person, very traditional and manual person. But of course, we need to combine digital and human this time. So the case has to do with this person. The name is Panos. He's an ophthalmologist doctor, 53 years old. There is a lot of worn dentition, about 7 millimeter reduced vertical dimension of occlusal. There is a lot of bone defect on 21 due to the occlusal trauma. There is occlusal disorder, anterior guidance loss, and extensive cervical erosion. Additionally, this patient, it was really funny. So we had the opportunity to get some nice, funny photos for this presentation. So we had to think about to do it like traditional, analog, I like analog, or to make it more digital. My opinion is always we need to combine. We need to combine the technology because we need the technology in order to work with modern materials, new techniques, more aesthetic techniques, and also to combine the human skills, the talent of the technicians in order to get the better results. So there is in the market now a system that we can work with pressable ceramics with a digital workflow. Let me explain. This is the previous situation of the patient, the portraits. So as we can see, there is a lot of erosions and really we cannot see any mandibular teeth. A lot of vertical dimension of occlusal loss, and we can see the lips, how the lips in the right photo, how the lips, it's getting down here. Okay, so we have aesthetic problems, a lot of erosions, there is no cusps, there's a flat occlusal areas. In the smile portrait, we cannot see any lower teeth, nothing. And of course, there is a different position of the lower jaw. It's more front because of the interruption of vertical dimension of occlusal. And this made a lot of fractures, chippings in the enamel of the 6 anterior teeth, the facial surfaces of decompressed forces. As we can see here, the vertical dimension with calm muscle tone, and then with occlusal. I'm going back, I'm going forward, I'm going back and forward. There is a big difference. And also the intermaxillary space between centric relation and vertical dimension in rest position, it was huge, about 10 millimeters. So we had to restore all this distance. It was a big volume and a big space. Intraoral photos, close up, a lot of erosions, missing parts of enamel, facial parts of enamel, posterior, anterior, really disaster. No occlusal and cusps, nothing, everything was flat surface, lateral views. And there was another problem on the tooth 21, 9 for USA. it was compromised with moderate to poor prognosis, but after the occlusal equilibration and the surgical periodontal therapy with bone graft, the mobility was less. We can see here, the problem it was that the patient, we wanted to extract and put an implant, but the patient didn't want to do that. It was afraid. He said, no, let it like this, and when I miss the tooth, I will put an implant, but not now, or a bridge. He was afraid, he didn't want to extract the tooth and put an implant. More close-up photos, we can see the problem with a 21 central occlusal views, a lot of enamel. So we had to think what kind of restoration we need to do. Crowns, partial veneers. Of course, we needed something that if it was partial and minimal advancing, so something that we will get a good cementation. So we just focus mostly for glass ceramics. So it was not a lot of damage in the lingual and palatal surfaces. So we decided to make like 3 to 4 partial tabletops for the posteriors and veneers for the anterior teeth. Occlusal view for the lower anteriors and the posteriors. A lot of composites, fractures, erosions. So we decided not to touch the lingual surface, but to work to the occlusal, mesial, and distal and facial surface that it was the most of erosions. Maxillary, the same, was not so big erosions in the palatal surface. So we decided to keep them. And also the patient didn't want to grind a lot his teeth. He was afraid. Okay, what we did, first of all, we get the first scanning, intraoral scan, in order to do what? To make provisionals with nothing of preparations. There is no any preparation, nothing. The teeth as it is, with the erosions. The idea it was with these provisionals to verify the final vertical dimension of occlusal, to verify aesthetic and phonetic for the patient. As you can see, there is no any preparations. Mandibular scanning. And then we get occlusal records. We had prepared incisal guidance in order to verify how much we will increase the occlusal, the VDO. So we put it in the mouth, we put it on the anterior teeth, and we scan upper and lower, the upper and lower teeth. Then we proceed to make the first diagnostic models with printing without any preparation. And then we proceed to make provisionals. This is the acrylic provisionals. It was milling PMMA provisionals without any grinding of the natural teeth. Just we get over of this like a cells. And we didn't care about to be like supra or subgingival or whatever. The only thing it was to verify the video, phonetic, aesthetic, color, and position of the teeth. So we get some photos, some informations of these PMMA provisionals. And the comments of the patient, it was like, I like them. I like to be a little bit more round, not so square. So we tried, and I disagree about this because I told him that it's not possible before to have like a lot of fractures, a lot of aggressive details, and then to pass in a very smooth, round result. You will change your appearance, your aesthetic completely, and it will be very visible for your friends and relatives, whatever. So finally, he agreed, and just he wanted to make a little bit more bright colors, to change the color and make it a little bit more bright. Then, after 1 month, we proceed to the final scanning with preparations. We prepare the teeth, occlusal, facial surfaces, and veneers for the 6 anteriors. The high definition scanning. So we finish the scan, occlusal, record. We get the STL files. And then we have the first images of the STL files, upper and lower, lateral views, palatal, lingual views. You can see the preparations, and occlusal views. As you can see, we decide to make, the clinician decide to make a peripheral chamfer of the posterior teeth in order to get better cementation, a bigger surface of enamel for better cementation. And then in the lab, we proceed the lab work. First of all, margins, to verify the margins. For the lithium disilicate crowns. And then to verify the margins in order to make the alveolar model. We do both of work at the same time. So we proceed for the alveolar model. Insertion paths of the dies, alveolar dies. And relation upper and lower with a new vertical dimension of occlusal, and then we make some space for some difficult undercut areas, occlusal as well. areas that it will be make difficult to put the crowns in the final position. And then we proceed to make the full contour setup according the provisionals and according the altercast that we have. We work with opposite, we check with the antagonistic teeth with the altercast. So we have all the time info about the SPI and Wilson curves. Then we proceed to remove of the facial surface the amount of material in order to apply ceramic aesthetic material. So it will not be completely monolithic. It will be only palatal, occlusal monolithic, and facial layering, veneering. Then we adapt on the model. And the crowns of the library adapted in the margins. And it's ready. Then we get STL files about the alveolar models, alveolar dies, and STL files about the final restorations. Then we proceed to work with this system. Printing from a company Tekema and furnace for press and the software that will permit us to design, first of all, the models. In 50 microns accuracy, and then to design and to put on the table of the ring, of the pressable rings, direct the crowns, the digital crowns, without any wax, without any sprues, nothing. So we get the digital STL files of the crowns, and the software put them direct on a simulated table like the ring that we use for pressable, for pressing. Even the plug tank areas are printed. We have simulation with the walls of the ring. So direct in the software, we put the crowns on the ring, and then we get also the alveolar printed models and printing dies ready. And after printing, we have the base of the rings that we will use them for pressable technique, direct, printed the crowns and the space for the plank in this base. So there is no any human hand that puts screws or something. It's getting automatically from of the program in this position. Occlusal, another view. The details are really, really good, very fine, high definition printing, and we use this material, the nanolithium disilicate, for pressing. We combine between low translucent ingots and between A2 and A1. So we have the ring, we have the cases, we put the plastic ring together, and then we fill the ring with investment material for pressables. We remove, and it's ready after about 30 minutes to put it in the burnout furnace. At least after 1 hour, we get it out, and then we put the ingots. We can combine between 1, 2, or 3 different ingots at the same time, at the same pressing. and the press is simultaneously for all of them. We take them out, has to cool in the room temperature, and then with glass plastic sand, we remove the investment material, and the restorations are ready. Then we fit the cases in the models. We do the first foundation wash bake. And then it's time for the human factor. We apply ceramic, we do the veneering, layering, in order to get the aesthetic, translucent, color, effects. And this is the final restoration after cementation. The final portrait.
Hi guys, a warm smile from Greece, and don't forget, apart from basketball, we know how to make teeth. Yes. Enjoy.
This is the final portrait of the patient, and we finished. Thank you very much. Muchas gracias.